Okay, hello, good afternoon, everyone. Okay, happy Saturday. Welcome back to our December week one. Right, so hope you have your December notes ready. Yeah, we are starting our December notes today. Okay, we are doing our revision for today. Okay, we are revising for our Form 4, Chapter 11. Okay, so I hope your trial was okay. I hope your trial was well. Okay, if I'm not mistaken, you just had the trial, right? Okay, so what's gone is already gone lah. If you didn't revise for it, then it's okay. We'll focus on SPM instead. Okay, so before I move on, there is something that I want to remind you as for our December week 4. This is the last one of this year already. So this is September. Oh, sorry. Why do I keep saying September? Okay, this is December week 1. Next week is gonna be December week 2. And for next week, the following week is gonna be December week 3 and 4. So please check your schedule. We will combine week 3 and 4 in 1 week. Okay, so if you cannot attend both or if you cannot attend one, you can request video as usual because the last 2 weeks of December is going to be your holiday. Okay, it's going to be your year-end break of 2 weeks. Okay, you go for holiday for 2 weeks and we will continue as we come back as January week 1. Okay, so please take note. All right, so what are we doing today? We are revising for our chapter 11, our force and motion. Okay, and if you still remember, this is a very boring chapter. So it's most on calculation. Okay, so today I'll try to make it as interesting as I can, but hey, it's calculation. Okay, I can only do the best. Okay, I'll do my best to make it as boring as possible. Okay, so today we'll go into our ticker tape and our graph. Okay, since we are talking about velocity and all. Okay, this free fall thing I'll go into that next week. All right, so let's begin. Let's start with our motion. Okay, so what is a linear motion? Now, linear motion is anything that moves in a straight path. Okay, anything that moves in a straight line. So in this case, you have your distance and displacement, which is jarak and sasaran. Okay, jarak and sasaran. I hope you still remember what is this. Distance, jarak is the total path you travel. Okay, whereas displacement, sasaran is the straight line distance. Okay, straight line path between 2 points. So for example, if you move from, okay, you start here, you move to the right 5 meter, move up 5 meter, move to the left 5 meter. Now that's your total distance, that's your distance. But displacement is the straight line from your starting to your ending. Now that's your straight line distance. This is what we call displacement, sasaran. Okay, so for sasaran, displacement, I don't care how far you have traveled. I only care about the straight line between your starting and your ending point. That's all. Okay, which is this straight line here. So how do you measure distance or displacement? Okay, I'll ask for you to read this one. Okay, what meter rule, whatever, you know this lah. Okay, so you have your distance and displacement. So which brings us to the next one. You have your speed and velocity. If you use your distance and divide by time, you will get your speed, okay, which is called kelajuan. And if you use your displacement and divide by time, you will get your velocity. This is your halaju. Okay, so unit is the same, meter per second. It's just that the distance and displacement is different. That's why speed and velocity is also different. The meaning is the same. It's just that one is straight line, one is the total. So for the meaning, okay, what is average? Average is the total lah. You just take a total distance, you know, a total time. Okay, doesn't make much of a difference. So speed is defined as the rate of change of distance. Okay, kadar perubahan jarak. Okay, here's the thing. Whenever you see divide by time, you have to use the word rate of change. Okay, rate of change means divide by time. So distance divided by time is rate of change of distance. Kadar perubahan jarak. Since we know speed is distance, what? So velocity is the same meaning. Rate of change of displacement. Kadar perubahan sasaran. Okay, rate of change of displacement. So distance, displacement. So distance, displacement. Okay, so the next one, acceleration. So acceleration now is the change of velocity divided by time. Okay, so you use meter per second square because you divide by time twice. Okay, you divide by time once, it's going to be ms minus 1. You divide it by twice, it's going to be ms minus 2. So it is the rate of change of velocity. You see, time one. So rate of change of velocity. In this case, it's one more step. It has to be v minus u minus t, over t. Final velocity minus initial velocity. Okay, over time taken. So you have to minus in this case. Okay, it's slightly more step. Okay, but it's the same. Okay, so to put it simply, distance and displacement. Okay, this is called Pecutan, by the way. So if you take your distance, you divide by time, you will get speed. Okay, whereas if you use your displacement, you divide by time, you will get velocity. Okay, for both case, you divide by time, you will get acceleration. Okay, that's the difference. Okay, so in this case, there's no acceleration for each. Okay, acceleration goes for both. In both cases, you can find acceleration. Okay, so distance divided by time is the speed. So speed divided by time is acceleration. So what is speed? Speed is the rate of change of distance. Velocity is the rate of change, displacement. So acceleration is the rate of change of velocity or speed. It's the same. Okay, this should be pretty simple for you. And don't forget the unit, ms minus 1, ms minus 2. Okay, so let's go into our ticker timer. This is one of the most boring part, okay, because some of you still have no idea what it means. Okay, ticker timer is basically marking dots on the paper to show you how fast a trolley or something moves. Basically, this is the simplest form of a speed meter, a speedometer, okay, to show you how fast something moves. Okay, so they will pull on the paper, okay, it will make dots on the paper. So by studying the dots, you know how fast the trolley moves. Okay, if you don't understand this, very easy. Imagine your car has a leakage. Your car is dripping oil at the bottom. So as you drive from one end of the street to the other end, you will form dots on the road, isn't it? Okay, because your car is dripping oil, it's dripping oil on the road. So by studying the dots of the oil, I will know how fast your car moves, right? If the dots are very close to each other, that means you're driving very slowly, right? Because the dots are very close. Okay, but if your dots are very far from each other, that means you travel very far between each dot. That means you're going very fast. So by studying the dots, I'll know how fast your car moves. So now, instead of making dots on the road, you are making dots on the tape. Okay, so that's the ticker tape, your ticker timer. Okay, as easy as that. So before you start doing any ticker timer, they will give you this setting, 50 vibration per second or 50 hertz. What does it mean? Okay, 99% of the time it will be 50 hertz. Okay, 50 hertz, that means each dot is going to be 0.02 second. Okay, so from this dot to this dot takes 0.02 second. Okay, 0.02, 0.02, 0.02. So every dot is 0.02. Okay, so 7 dots here. Okay, that means you have 0.14 second here. That means this whole thing takes 0.14 second. Okay, remember, don't count the first dot. I've said this a million times and I'll say it again. Please don't count the first dot, because whenever you are counting time, you don't count the starting point. Okay, for example, if your tuition is from 10 to 12, you don't say 10, 11, 12. You don't count the first dot. You don't count the starting point. So it's 11, 12. It's 2 hours. Okay, so same thing. You count from the second point. You don't count the first dot. Okay, so it's 7 dots here. Okay, 0.14. Okay, so this should be pretty easy. So now you have the time of this tape. By measuring the length, you can you can use the length, okay, the displacement and the time to calculate the velocity, right? So by measuring the length and measuring the time, you can use the length and the time to calculate the velocity. Okay, here's the thing. Usually in your ticker tape, they will use 5 dots or 10 dots per strip. You see, in this case, you don't count the first dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's usually 5 or 10 dots because it's easier. Okay, they won't just put 6 dot or 7 dot because come on, who likes that number? Okay, it's going to be usually 5 or 10 because 5 or 10 is the easy number to count. Okay, so in this case, okay, 10 dots here. That means 10 times 0 0.02, so it's going to be 0 0.2. So this whole strip takes 0 0.2 seconds. Okay, and since we know this is 3 cm, so 3 cm divided by 0 0.2, you will get 15 cm per second. Okay, 15 cm per second. Okay, you might say, sir, I thought SI unit is meter per second. Yes, that is true, but we keep it in cm per second because if we change it to meter per second, it's going to be 0.15. 0.15 is not a very nice looking number. Okay, 15 looks nicer because it's easy to see. I mean, if you want, you can convert this to 0.15, no problem. But you're not gonna get extra marks from that. So there's no point converting. I mean, you want to convert, you can convert, but it doesn't make any sense. I mean, there's no extra mark for you. Why would you do extra work? So just keep it in cm per second form. Okay, since they give it in cm, you just keep it in cm. Okay, so distance divided by time, you get velocity, displacement, whatever. Okay, so for acceleration, now this is slightly more difficult, but it's not that difficult. Okay, here's the thing. Before they tell you to do this, they will put an arrow here, okay, and then they will say direction. Okay, what does the arrow mean? Arrow means where you start. Okay, you start here. Okay, arrow means you start here. So since we start here, right? Since we know acceleration is v minus u over t, we have to know which is the u, which is the v. So we know that u is the initial, right? Starting, right? So u is definitely this strip. This is the starting. V is the ending. This one. Okay, so how many dots for each strip? So don't count the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 dots here. So we know that each dot is 0 0.02. So every dot is 0 0.2, 0 0.2, and 0 0.2. Okay, so every dot is 10 lah. Everything is 10 dots lah. So 0.2 for each. So now you should be able to count your initial velocity. Okay, you calculate your initial velocity. We know that the length is 1.5, the time is 0 0.2. So initial velocity 1.5 divided by 0 0.2, we get 7.5 cm per second. Okay, and then the final, okay, 7.5 divided by 0 0.2, you should get 37.5 cm per second. So now you have your u, you have your v, right? So what about t, total t? Okay, many will fall into trap here. Many will just think, oh, 4 strips, right? Each strip is 0 0.2, right? So now the time is 0 0.8. Wrong. Okay, wrong, very wrong. Why? Because like I said, when you count the velocity for each strip, you don't count the first dot. So it's 10 dots here, right? And to calculate the acceleration, when you want to count the total time, same concept, you don't count the first strip. Just now velocity, you don't count the first dot. Now acceleration, you don't count the first strip. So instead of having 4 strips, now you have 3 strips. Okay, 3 instead of 4. So now it's actually 4 minus 1 times 0 0.2. Okay, not 4 times 0 0.2. So instead of 0 0.8, you should get 0 0.6. Okay, so in this case, u v minus u divided by 0 0.6, you should get 50 cm per second square. Okay, take note of the 2, because this is acceleration, this is not velocity. Okay, so this is not -1. Okay, so remember the time, you don't count the first strip. Let me repeat this again. When you calculate the velocity, you don't count the first dot. When you calculate acceleration, the time, you don't count the first strip. So it's actually just 3 strips. Yeah, easy, so this is a trap, many will fall into this trap. So just be careful. Okay, so it's not hard. I don't find what's hard about this thing. Many students say that this part is hard. Maybe I don't see where. This is a bit tricky. Okay, so let's look at the type of motion. Okay, as I said, the arrow points to where you start. Okay, if you start here, if the dot is uniform, okay, this is uniform velocity. How large is the dot? If you start here, okay, the dot becomes further and further and further. That means this is uniform acceleration. I'm increasing my speed. If I start here, the dots become closer and closer and closer. That means this is uniform deceleration. Nya berjutan. I'm decreasing my speed. I'm becoming slower. Okay, so if this is like inside, that means this is non-regular, non-uniform velocity. Okay, so let's look at our very confusing part. Okay, let's go to our motion graph. This is the most hated part because it's so confusing. Okay, but it is not, I'll show you. Okay, so you have two graphs to study here. We have our displacement time graph and our velocity time graph. Okay, so what's the difference? Okay, displacement time graph shows your displacement in your time, and of course, this shows you the velocity in the time. Okay, so this is quite easy actually. Okay, so what we care about is the gradient. Okay, the gradient. For displacement time graph, we only look at the gradient. Okay, the gradient is the velocity. Why? Because you see, gradient is y divided by x, right? You learn in your maths, right? Gradient is y divided by x. So y divided by x is displacement divided by time. Okay, y divided by x, y is displacement, x is time. So displacement divided by time. So as we know, displacement divided by time is velocity. Okay, so in this case, gradient, which is y divided by x, is the velocity. That's all, really easy. So you see, positive gradient going up, positive gradient, positive velocity. That means the car is moving forward. Positive velocity means moving forward. Okay, flat line. If the line is flat, means gradient is zero. If gradient is zero, velocity is zero. Zero gradient, zero velocity. That means this is zero velocity. The car is not moving. Zero velocity means the car is staying somewhere. You see, 50 meter is staying there. The car is not moving. And then positive gradient again, positive velocity, the car is moving forward again. Okay, and then negative gradient, negative velocity means the car is moving backward. Negative velocity means going back. So you see, go back to where? Going back to the original point. That means the car is starting at here. The car moves forward 50 meter. The car stays at 50 meter. The car moves forward another 50 meter to 100. And then the car goes back. Okay, from 100 goes back to 0. So forward, stay, forward, go back to 0. So that's the displacement time graph. Okay, so now velocity time graph is a bit confusing because now not only we look at the gradient, we also look at the area. Okay, so since we're using the same concept just now, gradient is y divided by x. So velocity divided by time. What is it? Velocity divided by time is acceleration. This is why gradient for velocity time graph is the acceleration. And then area. Area is x times y. So x times y, velocity times time. Okay, if you use velocity times time, you will get displacement. So for the area of velocity time graph, you get displacement. This is the displacement. Okay, so for the velocity time graph, it's very different. Just now, positive gradient, positive velocity. That means the car is moving forward. Now, positive gradient, positive acceleration. Positive acceleration means the car is accelerating forward. Instead of moving forward, now it's accelerating forward. Still moving forward, but it's becoming faster. Okay, and then zero gradient, zero acceleration. Okay, zero acceleration doesn't mean you're stopping. It means you're moving forward at a constant speed. When your dad is driving 80 on a highway, staying at 80, his acceleration is zero. He's not becoming any faster. What that doesn't mean he's not moving. He's still moving forward. You see? So that's the difference. Just now, move forward, stay, not moving. Now, move forward, still move forward. Accelerating forward, stay constant speed forward. Okay, steadily moving forward. And then negative gradient. Okay, negative gradient means negative acceleration. Negative acceleration means I'm braking my car. I'm stepping on the brake. Okay, I'm becoming slower, but I'm still moving forward. So I'm still moving forward. So you see, going forward faster, going forward steady, going forward slower. I'm still moving forward. Whereas this one is moving forward, stay, forward, backward. So the moving down is going backward in displacement time graph. The moving down is slowing down. So you have to look at the meaning of the gradient. Okay, whereas the area here is the displacement. Here, we don't look at the area. The area means nothing. If you're very confused, you can actually look at this just now. Okay, so your displacement time graph, if we look at the gradient, that means divided by time, we are looking at the velocity. Why don't we look at the area? Because if we times time, we look at the area, there's nothing here. Okay, nothing is above displacement. But for velocity, if we look at the gradient, okay, divided by time, we are looking at the acceleration. But when we are looking at area, when we go up, we are looking at the displacement. This is why velocity, we look at the area and we look at the gradient. Displacement, we only look at the gradient. We don't look at the area because it has no meaning. Okay, there's no gradient here. Sorry, there's no area here. Okay, so in this case, in your exam, you should always write this out. Displacement time graph, the gradient is the velocity. Okay, for velocity time graph, the gradient is the acceleration. The area is the displacement. Okay, you should write this out always. It's not really confusing. You should always know this gradient is v minus y divided by x. And you should know. Okay, so anyway, let's go to the exercise. Okay, shall we? The best way by doing this, by revising this, okay, by doing the exercise. Okay, so let's go to question 3 because question 1 is inertia. We're gonna go into that next week. Question 2 is also inertia, also next week. Let's go into question 3, section B. Okay, this is page 3, I guess. Page 4. Okay, so section B, solve the following problem. An athlete runs 200 meters in 15 seconds. This can be 200 divided by 15. Okay, displacement divided by time. So 200 divided by 15, you get 13.3 meters per second. Okay, so B, a car travels at an average speed of 90 kilometers per hour. How far does it travel in 4 hours? So we know 1 hour, this thing travels by 90. So 4 hours, 90 times 4. Okay, if you keep driving 90, you will travel 360 km in 4 hours. Okay, you almost reach Penang lah. Okay, Penang is almost 300 something kilometers. Okay, so 360 kilometers. Basically, speed times time, you get back your distance for this distance. Okay, so C, a car accelerates from rest. Okay, take note, when you see from rest, automatically write down U equals to 0. Okay, make it a habit. Dari pergun. Whenever you see pergun, that means from rest, U equals to 0. Write this down. Okay, because the 40 here is the V. The car goes from rest to 40 in 3 seconds. This is the T. Because in exam, they won't just tell you, okay, a car starts from speed 0, goes to speed 40. They are not going to be that obvious. They are just going to say, okay, it starts from rest, okay, to 40. So determine the acceleration. So acceleration is V minus U divided by T. We know that V is 40. Okay, although U is 0, you still need to write minus 0. Okay, because I got students gonna penalize by this. He didn't write minus 0. He just write 40 divided by 3. The teacher gave him wrong because he didn't express the U out. I know it sounds very stupid, but still you will get penalized for this. Okay, so 13.3 meter per second square. This is negative 2, so that's your A. Okay, negative 1 is your B. Okay, so next, number 4. If I'm going too fast, let me know. I'll slow down for you. Okay, so number 4. A boy cycles 12 kilometers in 3 hours. Okay, that means 3 hours here. And 3 kilometers in 1 hour in the opposite direction. So here another 1 hour. Diagram below shows his journey. Okay, so this is how he moves. So this is the distance now. Okay, for displacement is going to be here to here. This is the distance. So what is the speed of the bicycle from P to Q? So this is only one way. I don't care whether speed or displacement. Okay, speed or velocity, since I know this one. So 12 divided by 3, I get 4 kilometers per hour. Again, don't convert. Sorry. Okay, don't go and simple go and convert. It's not important to convert. If they give you in km, you just give it in km. If they give you hour, then you give it in hour. Okay, so B, what is the total displacement traveled by the boy? So 12 here, 3 there. You should get 9 km. It was here to here is 9. Okay, if it's distance, then it's 15. Okay, if it is distance, then it's 15. So calculate the velocity of the bicycle. Velocity is by using the displacement divided by time. Total time is still 4 hours. Time doesn't change. You don't minus off the time. You still use the total time. Okay, so 9 divided by 4, get 2.25. If they're asking for speed, then it's 15 divided by 4. That is 3.75. That's the speed. The speed I'm using the total. Velocity I'm using the only straight line. That's why there's a difference in the answer. The meaning is the same. It's just that the answer is different because the displacement and displacement and distance is different. Okay, so next, let's go to number 5. Solve the following problem. 100-meter runner runs 100 meters in 12 seconds. 100 divided by 12. Get 8.33 per second. Okay, so B, a car starts from rest. Again, like I said, when you see from rest, automatically put U equals to 0. And writing like this. Writing out in. Okay, so speed uniformly to 40 in 10 seconds. So this is T equals to B minus U divided by T, 40 minus 0 over 10. So we should get 4 meters per second square. Where 2 because it's acceleration. Okay, next C. A man walks 500 meters from P to Q, then another 1200 to R. The time taken to get from P to R is 3 minutes 20 seconds. Okay, so now it's a mix of time. Now you have to convert because you cannot use meter and second. Okay, you have to convert everything to second. So 3 minutes is 180 seconds plus 20 seconds is going to be 200 seconds. This case you convert because you cannot use a mixture of 2 units. So he walks, okay, let me draw this out from P to Q, 500, and to R, 1200. So total distance, 500 plus 1200, get 1700. Okay, then the man's speed. Speed, I can just use distance. Please take note of the word. If they're asking for velocity, now you cannot use distance already. You have to use displacement. So So should be 1007 divided by 200. Okay, should be pretty straightforward, very easy. So number 6, Azmi rides his motorcycle to the north of 24 kilometer. Okay, then to the west for 12, then finally to the south for 12 before stopping on the rest. His journey takes 2 hours. The whole thing is 2 hours. Okay, so A, what is the distance traveled by Azmi? So distance is going to be 24 plus 12 plus 12. Okay, so it's going to be 48 kilometers. That's the distance. Okay, guys, distance now for the displacement is very different. Displacement is from here to here. Okay, so what is it going to be? We're going to do triangle now. Okay, so this is 12. So 24 is here. 12 is here. So this is going to be 12. 24 minus 12. Okay, so how do you calculate this? That's your Pythagoras. So 12 square plus 12 square root, which is square root 288. So 12 square is 144. 144 plus 144 is 288. And then square root of 288 is 16.97. Okay, 2 decimal point, 16.97. See, very different. Okay, one is the total, one is the straight line. Okay, very different. So how about the average speed? When they want speed, means you can use distance 48 divided by 2 hours. So 24 kilometers per hour. So average velocity, velocity is going to use this. So 16.97 divided by 2. Get 8.485, 8.49 lah. So answer very different because the distance and displacement is different. Okay, you see, very different here. So of course, very different here. Okay, so moving on, let's go to number 7. A netball player has been instructed by his coach to run around the netball court before the game begins. Okay, so below shows the size of the netball court. The player runs from W to X, X to Y, stops at Z. So W to X, Y, Y to Z. So he's running like this. Okay, so time is 20 seconds. So state the distance from W to Z, which is here, plus here, plus here. 28 plus 22, 28. I get 78 meters. Okay, distance so the displacement, there's no calculation, 22. Speed, now speed is by distance. So 78 divided by 20 seconds. This is 3.9 per second. So average velocity, velocity is going to go 22 divided by. Okay, as you see here, distance, displacement different, speed, velocity different. Exam is not going to be this easy lah. You think they'll give you 8 marks for this? Okay, just wish lah. You really know. Okay, so next, let's look at our ticker timer, ticker tape. So diagram below shows the result of an experiment carried out by a student to study the motion of a trolley. So this is our U, this is V, this is starting. So there should be 2 dots here lah. Okay, draw it out. or D got covered. So let's count the dot. Don't count the first dot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every one of you got 10 dot. So everyone is 0.2 seconds. If you look at the down there, you also know lah. You see one strip 0.2, 0.4, 6, 8, 10. Every strip is 0.2. That means you know it is 10 dot. So based on the diagram, we'll state the type of motion. So what is it like? Can you see the velocity is increasing? Not. Okay, the length is increasing. Okay, so the type of motion. Since this is the motion, the velocity is increasing, I can say uniform acceleration. The car is becoming faster. Uniform acceleration. Or you can say increasing velocity is the same. Okay, how laju meningkat can. So B, what is the RV in this experiment? The responding, it's your. Okay, what are we trying to control here? We are trying to control the slope, the inclined plane. Okay, the more inclined you float, the faster you go down. So the responding is this one, the acceleration. Okay, so the steeper you put, the higher, the faster they accelerate. So C, predict the length of the 6 ticker tape. So you have 5 tapes here. So 10, it should be 12.5 because it's in the middle. 15. So every box you jump 2.5. So 15 to 17.5. 17.5 to 20. 20 to 22.5. Okay, so D, the frequency of the timer is 50. Calculate the acceleration. So acceleration is V minus U divided by T. Let's calculate the V first. Okay, V is here. Okay, V is 20 divided by 0.2. So I should get 100 meter per second. Okay, length divided by time. So same thing for U. 10 divided by 0.2. So I should get 50 meter per second. So how about the total time? Like I said, you don't count the first strip. So how many strips here? 1, 2, 4. So it's going to be 8 seconds. Okay, so A is equal to V minus U divided by T. Okay, so 50 divided by 0.8, I get 62.5 seconds squared. 2, see, this is not 1, please don't say 1, 2, 3, 4, 5. Yay, 5 times 0.2, that is 1. No, it's 0.8 minus off 1 strip. Okay, we only minus off strips when it comes to time. Don't just say, oh, minus off 1 strip means this is the U. No, the U is still the first strip. When we count the time, we don't count the first one. Okay, so number 9, the diagram below shows the 5 strips of ticker tape produced by experiment. So obviously, this is the U and this is the V. Okay, for your convenience, they already give you the velocity. You don't need to count one by one. Okay, so the first one is 30. B, they didn't give you. The second one is C. The C is 40. Okay, so it's going to be 35. 35. Okay, so about 10 dots here, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so every strip is 0.2. Okay, so B, calculate the acceleration. So now you don't even need to calculate the U and the V because it's already given to you. This is the U, this is the V. Okay, so the time is going to be minus of 1 strip. Okay, so it's 1, 2, 3, 4. So 4 straight and 0.2. So A is 50 minus 30. 4 times 0.2. So it's 20 over 0.8. It's 25. So cm. Cm second square. So see what is the relationship between length and time. Okay, as time increase, length increase. As you can see here. Okay, time increase, length increase. So I'm just gonna write it this way. Okay, I'm not gonna write sentence, just too much trouble. Okay, so based on the diagram above, state the type of motion. As you can see, it is uniform acceleration. Same as just now. Okay, kejutan tetap. Predict the length of 6 tape. Okay, so 6, 7, 8, 9, 10. So the next one, 11. Okay, so moving on. The next one. Again, you have your. Okay, so look at the arrow. Let me just start here. So this is the U, this is the V. This time is a bit different. They use 5 dots instead. So 1, 2, 3, 4, 5 dots. So they already show you the length here. Okay, 1, 2, 3, 4, 5. So draw the histogram. So 1, 2. So state the relationship between length and time. As I said, length increases as time increases. This itself. So for histogram A, state the type of motion, uniform acceleration, same answer. We did the length of the 6 tape. Aduh, 6 cm lah. Okay, so calculate the initial and final velocity. So U and V. Okay, so now 5 dots is going to be 0.1 second, not 0.2. Because each dot is 0.02, remember? So 5 times 0.02 is going to be 0.1. So each length, each time is going to be 0.1 second. So for the initial U is 1 over 0.1 because 1 cm, what? 0.1 second, what? So you get 10 meter per second. So V is going to be 5. Okay, so 50 cm per second. Okay, so that's the U and V. Oh, you can write this here, sorry. I'm writing up there. So calculate the acceleration. So acceleration is V minus U over T. So how many strips here? So we have 1, 2, 3, 4, 5 minus the first one. So 4 strip. 4 times 0.1. Okay, so 50 minus 10 over 4 times 0.1. So you get 100. Okay, 2, I remember. What's the acceleration? Okay, I'm making this fast because it's very boring. Yeah, I'm sure you think so too. So next, number 12, this is our displacement time graph already. Okay, displacement time graph, so calculate the total displacement of the object. Okay, so let's see how this comes. Okay, before that, make it a good habit and write what's the gradient. So what's the gradient? Gradient is velocity. What's displacement divided by time? So how does the car move? The car moves forward 30 meter, and the car stays there. The car moves backward 30 meter, and move to behind some more 25. Negative 25 means back some more 25, and then moves forward another 25. So the car starts here, the car ends at 0. So the for displacement, I don't care whether how much you move. I only care about the starting point and the ending point. So start at 0, end at 0. So the displacement is 0, 0 meter. Because start and end at the same point. So distance, now distance is different. I want the total. So 30, the car moves forward for 30, another 30, because move backward, and then for 25, another forward 25. So that's the distance. You see, distance I want total 30, 30, 25, 25. I get 110. That's the total distance. So now the velocity from 0 to 5 seconds, which is from here to here. What's the velocity? So you calculate velocity means they want the gradient. It means v y over x. So y is 30, x is 5. So 30 divided by 5, which is 6. This end. Okay, 6 meters per second. Because this is 30 one. This is 5 one. So 5 to 12, what's the velocity? 5 to 12, the line is flat. Flat line means 0 gradient. 0 gradient means 0 velocity. Okay, 0 meter per second. Okay, so calculate the average velocity and the average speed. Now we have to split this into two. Average velocity, we have to use the displacement. This one. Okay, so this, how long does it take out the whole thing? 20 seconds. So velocity is 0 by 20, which is 0. Okay, because the displacement is 0. As for the speed, it's gonna be 110 here. So 110 divided by 20, 5.5 meters per second. So draw the acceleration time graph. This is not our concern. We don't study acceleration time graph. Okay, so as you can see, velocity and speed is very different because distance and displacement is very different. Hence the answer difference. Okay, so let's look at question 13. Okay, I'm not going to discuss too much today, because it can get very boring. Okay, you know what? I'm going to do one more and then we shall dismiss. So the diagram below shows the graph of displacement versus time. So this is a displacement time graph. And as I said, always make it a good habit. Okay, gradient is velocity. So mark and write for the displacement for the boy after 15 seconds in the diagram above. So how does he move? He moves forward, he stays, he moves forward again, and then he goes back to 0. So for 15 seconds, how far has he moved? He has moved for 6 meters. Okay, so you see, he moved forward for 4, he stayed, he moved forward another 4, he moves back for 2. So I don't care how far he traveled, I just care about from 0 to where he is, at 6 meters. Okay, so B, what is the situation of the boy from 5th to 10 seconds? So from 5th to 10 seconds, he's staying there, he's not moving. Okay, so he's stationary. Okay, or at rest. Okay, stationary or rest. He's not moving. So from 12 to 28, what happens? The boy is going backward. Okay, the boy is going backward. So it's negative. Not acceleration, negative acceleration means it's slowing down. So no. This is how large. C. So C, calculate the displacement made by the boy from 10 to 12 seconds. 10 to 12 seconds, he's going from 4 meter to 8 meter. Okay, so the change is 4 meter. So 4 to 8. So state the time of motion of the boy at 12 to 28 seconds. Let me just explain this. Negative velocity. Okay, so you know what? I think I'm going to stop here because the rest of the question, I think you can do it yourself. I'm not going to just keep going. It gets boring already. Okay, so I will continue with this next week. Next week we shall go into free fall and inertia. Inertia is actually more important than this part. Okay, inertia is confirmed coming out in exam. This one I'm not sure. Okay, whether they come out or not, it depends on this year if they want to torture you or not. Most likely not lah, because this is something new. Okay, new in the syllabus. All right, so I'm gonna stop here. I will see you again next week. Okay, thanks for coming. Hope you have an awesome weekend. Okay, see you next week. Take care and bye-bye.